Okay.
Yes, sir.
Chalo. Energy of a particle in SHM beta. Energy of a particle in SHM. Any oscillating body beta in SHM will possess both kinetic energy and potential energy. Okay. An oscillating body or you can say an oscillating particle. An oscillating particle possess your kinetic energy and potential energy. Kinetic energy and potential energy. It possesses both the potential energy and as well as of your kinetic energy. Can you tell me kinetic energy is possessed by what beta? By the motion of the particles. Potential energy has been possessed by the virtue of its configuration. That means position of the particle.
Yes, sir.
Take the first side heading, potential energy. First one is your potential energy. Potential energy. So potential energy is being possessed by the displacement beta due to the virtue of its displacement. Due to its position, the potential energy is being possessed. Like in work per energy, potential energy is what beta? F is equals to minus of du by dx, that is equals to mg into h. అవునా కదా?
Yes, sir.
Potential energy is equals to mg into h. Height లేకపోతే potential energy ఉండదు. So that is the basic conditions what we have done it. Our potential energy was been given by the formula F is equals to your minus of du by your dr. Negative potential gradient is known as of your conservative force. F is equals to minus of du by your dr, isn't it?
Yes,
Second
sir.
right here, potential energy. The potential energy is because of displacement. Is because of your displacement from mean position. From mean position. Okay. So the particle is it a displacement x from the mean position beta. Like say for example, if this is your particle which has been oscillating, like in a simple pendulum, if I'm taking right now, this is your mean position. So I'm going from mean position to some extreme position right now. So from here to here I have been gone. This one is say for example x, making an angle of a theta. So it will possess the potential energy with respect to this height only, no?
Yes, sir.
With respect to this height. Okay, so
Yes,
if
sir.
there is no height, there is no potential energy for the given condition. So the potential energy of the body is because of the displacement from the mean position. This is your mean position to this one is your extreme position. Mean position to your extreme position part of a relation, isn't it? So I can
Yes.
say that say the particle, is at a displacement x from mean position. X from your mean position. X from your mean position. So work done in displacing from here to here is against the restoring force beta, because restoring force is acting on the body in which direction? Opposite direction, gather.
Yes,
Because
sir.
when you take this body from the mean position and take it to some extreme position, leave it. What happens? This body will come back to the mean position because of your restoring force.
Restoring force.
So
Yes.
work done it by your, like say for example dx against the restoring force is given by the formula, like say work done in displacing it by your dx against restoring force F is equals to how much? K into your x is. How to write the work done formula? Can you tell me better? Work done formula is written as dw is equals to work done is equals to force into displacement. Antena? Work done
Yes,
is
sir.
equals to force into your displacement. It is F dot into dx. or that is equals to f into your dx into your cos of your theta, isn't it? So now what is the value of force? Already we got f is equals to your k into x. Substitute that value of the force in the place of this one. F is equals to k into x. ఇక్కడ substitute చేసుకో. What is the angle between f and dx? Can you tell me better? What will be the angle between f and dx? Force is in this direction. Displacement is in the opposite direction. అవునా కదా? ఎందుకంటే force
Yes,
ఏమో
sir.
mean position కి act అవుతుంటది. Displacement is in opposite direction. So angle between them will become how much? If the force is like this, from the mean position, the displacement is like this. Obviously, angle between them will be equal to how much? 180 degrees.
Yes, sir.
I can write here right now. dw is equals to, I can write here, dw is equals to your, that is nothing but k into your x into your dx into your cos of your 180. Cos 180 is how much? Minus of 1. So it is minus of k or k x into your dx. So this will be your work done.
Yes, sir.
So this work done is stored as potential energy beta. So this u is equals to minus of your dw. ఇది already మనము work for energy నేర్చుకున్నాము.
Yes, sir.
Potential energy is equal to your minus of negative of your work done. So integrating on both the sides. Integrating on both sides. Integrating on both the sides. So how do you integrate this one? See, integral of your du from where? From initial potential energy 0 to final potential energy, say for example u is equals to integral of minus of dw. Dw value this one, minus minus will become for me plus. So this will become for me k into your x into your dx. Limit will be from 0 to your x. So integral of du is nothing but of your u, upper limit minus lower limit చేసుకుంటే u అవుతుంది. So in this one k is out. Integral of your x into dx, integral of your x into dx, limit is 0 to your x. So u is equals to k into integral of x into dx is how much beta? Integral of your x to the power of your n into dx is equals to how much for me? X
N plus
n
1.
plus 1
N
plus
plus
1.
1.
1 kada. So
Yes, sir.
1 plus 1 is 2
X square.
x square divided by limit will be from 0 to your x. So u is equals to how much it will, if I'm subtracting upper limit minus lower limit, in the place of x, x square, lower limit is 0 square divided by 2, it is 0. So this will
Yes,
become
sir.
for me how much? U is equal to half into k into your x square. So
Yes,
this
sir.
is the potential energy particle. U is equals to half into k into your x square. Where is the value of k beta here? K is equals to, where k is equals to your m into your omega square. How I got this value beta? Because we know the acceleration a is equals to minus of your omega square into your x part of relation. అవునా
Yes,
కదా?
sir.
Omega square into your x.
Okay,
Okay.
taking
So
one.
if I multiply, yeah, on the both the side, if I multiply by your m, so this one will be equal to m into your a is equals to minus of your m into your omega square into x. So this force will be equal to, this total is a constant k into your x. So that is the reason I have taken the value of k is equals to your m into your omega square. So k
Yes, sir.
value will be equal to how much for m into omega square. So this will be equal to how much for me? Your u is equals to, u is equals to your half into your m into your omega square into your x square. So this will be the potential energy of your particle which is been oscillating to and fro motion. U is equals to half into m into omega square into x square. Okay.
Yes,
So
sir.
x can be anything. At mean position x will become how much? 0. At extreme position x will become for me how much? A. అంతే కదా. If this is
Yes,
a
sir.
particle which is oscillating on a straight line, ఇది mean position అనుకుందాం. If this is your mean position, if this is your mean position, here x will be equal to 0. If this is your extreme position, x will be equal to your plus a. If this is your extreme position on your left hand side, here x will be equal to minus a.
Yes, sir.
Displacement can be either positive or negative. So if I'm writing here at x is equals to plus or minus of your a, potential energy will become for me u is equals to your maximum, that is equals to your half into k into your a square. That may be positive or that may be your negative part of relation. So u max is equals to your half into k into your a square part of relation. Is that clear? And
Yes.
potential energy is minimum where beta? at x is equals to 0. అంతే కదా, mean
Yes, sir.
position. At your mean position, I can say. Okay, at x is equals to mean. That means u mean is equals to half into k into, in the place of x, it is 0 square. That means minimum potential energy will become how much for me? 0. Okay, so
Yes.
this is a formula. Potential energy U is equals to how much for me? Half into m into your omega square into your x square participation. X can be at the mean position 0, and at extreme position x will be equal to maximum displacement of the particle. Okay, in the
Yes.
same way, if I'm kinetic energy, kinetic energy is because of what, beta? Because of the motion. అంతే కదా, half into
Yes, sir.
m into v. Velocity అనేది ఉండాలి ఆ particle కి. Then only that body will possess me what? Kinetic energy participation. Now tell me, what is the velocity of the displacement x, beta, for an SHM? For an SHM participation, when I have taken here right now at a certain position, the velocity of the particle can be given by the relation velocity as a function of x. చెప్పు, velocity at a displacement x, at your displacement x from mean position, from your mean position, from your mean position. What is the formula? V is equals to omega into under root of your, this one is a square minus of your x square. Antena?
Yes, sir.
So kinetic energy is equals to, what is the formula? Half into m into your v square. So that will become for me half into your m into v square will become how much for me? Omega square into your a square minus of your x
X
square.
square.
Half into m is what, beta? Just now I told you. Half into m is nothing but what? Half, sorry, m into omega square is how much for me? K.
Here.
So I can write here, in this given condition, m into omega square is equals to, this one is half into k into this one is your a square minus of your x square. So this is your kinetic energy formula. So kinetic energy is equals to how much for me? Kinetic energy is equals to half into your k into a square minus x square, where k is equals to how much, beta? M into your omega square. Okay, na?
Yes.
Now tell me at mean position, what is the velocity? What is the kinetic energy, beta? At x is equals to 0. At x is equals to 0 means what position? Mean position. At mean position. Okay, so kinetic energy will be,
Yes.
kinetic energy, ఇది x 0 అయిపోతుంది.
Yes, sir.
A square minus 0 is nothing but a square only, na?
Yes, sir.
So kinetic energy will become for me maximum kinetic energy. That will be equal to half into your k into
Yes,
your a.
sir.
అంతే కదా?
Yes.
This kinetic energy is maximum at mean position, which is same as what? Total energy, beta. I'll tell you that one. So this is your maximum kinetic energy at your mean position. Now tell me at extreme position, at x is equals to plus or minus of your a. Now in the place of x, you take your a.
Yes, sir.
How much it will be getting?
0, sir. So
0. That means if positive extreme or negative extreme participation, kinetic energy will be equal to your minimum. So minimum kinetic energy will be equal to 0. Minimum kinetic energy will be 0.
yes,
It is
sir.
at what position? At your
Extreme.
extreme position. So this one is at your extreme position. At extreme position, kinetic energy is minimum. Now tell me, what is the total energy? So total energy is equals to total energy. So what is the total energy, beta? Total energy is sum of your potential energy and kinetic energy. So
Yes.
E is equal to your kinetic energy plus of your potential energy. So kinetic energy formula is how much for me? Half into k into your a square minus of your x square plus potential energy is half into k into your x square. So this will become for me E is equals to half into k into your a square minus half into k into your x square plus half into k into your x square. Anything is getting cancelled, you see.
X is half, 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 sir.
What's better?
We can cancel halves, right, sir? All 1/2s.
Yeah. This is negative and this is positive.
Okay,
Na?
yes, sir.
It will get cancelled.
Yes, sir.
So total energy will become how much for me? E is equals
Yes,
to half K into your A square.
yes,
Okay. మన దగ్గర చూడు kinetic energy at the mean position is also how much for me? Same.
half K.
So I can say that yeah, minimum kinetic energy is exactly equal to what beta? So
Total
I can
energy.
say that maximum kinetic energy at mean position is same as what? Total energy is same as of your total energy. Adugutaడు complete examinations la. So this is half your K into A square, and maximum kinetic energy is also half into K into A square. At what position? At your mean position. Okay na?
Yes,
If I take the graph of this one beta, it'll take care itself. Potential energy, what is the formula beta? See? Potential energy is equals to half into K into A square. It means U is directly proportional to A square. Isn't it?
yes,
So if U is directly proportional to your U square, it will be parabola in the upward direction. So the graph will be like this. Like this. Parabola in the upward direction. So this is your potential energy. Kinetic energy you see right now here. Kinetic energy is directly proportional to right now. If I'm writing the kinetic energy particulation, this is it your positive A plus A, and this one is at your negative
negative.
minus A particulation. Okay. The same way, kinetic energy will be the parabola in the downward like this. Like this. So this one is your kinetic energy. So the line joining both of this one will be the total energy. So this white line, it is touching the red and it is touching the green. So this will be your total energy. That is nothing but of your E. So this is the graph of your energy versus your position. Okay. So one is parabola in the upward direction, another one is parabola in the downward direction with respect to your x part. In the kinetic energy formula is how much for me better? Half into K into your A square minus of x square. So we are having a negative term right now. So kinetic energy is directly proportional to your x square, whereas minus of x square beta. Whereas potential energy is directly proportional to x square. అంతే కదా? U is directly proportional to your x square, and here kinetic energy is directly proportional to minus of x square. This is general formula, isn't it? It's totally a constant. This is totally a constant part of relation. Okay, so this will be the minus of x square. That is the reason we are getting the potential energy for this one in the upward direction. Okay.
Yes.
Give you a small note. At mean position, potential energy is minimum. Potential energy is minimum, but it need not be zero. It need not be zero always. Okay. It means if I am talking from the origin right now like this, this was the graph. This is the potential energy versus your position. It can also be something like this. Okay. So this is your U and this is your X. If the potential energy is minimum and it is not zero at origin, that means this graph may be like this. So somewhere here at a position of your X naught, this is your X అనుకుంది. U will be your minimum. అంటే నీకు ఈక్వేషన్ లో వచ్చింది అనుకో, U is equals to U naught plus of your half into K into X square. Then it is not zero కదా at origin. అందుకోసం it is having some constant. So that constant energy I'm taking it as of your U minimum here right now. Okay.
Yes.
If it is at origin, it will pass from the graph, the first graph. If it is not passing from the origin, means it is already having certain potential energy, means this is the graph you need to draw for the given condition. Okay.
Yes.
So that was about your energies of your kinetic energy and as well as of your potential energy. Let me do some problems on this one. See this problem better. The potential energy of a particle, the potential energy of a particle performing SHM is given as U is equals to 15 plus X minus 1 whole square. If the total mechanical energy, if your total mechanical energy is 27 joule, total mechanical energy means total energy beta.
Yes.
Find the number one mean position. We need to find out the mean position. And number two, we need to find out the maximum kinetic energy. Maximum kinetic energy of the particle. Maximum kinetic energy of the particle. Okay. So what is given for me beta? U is equals to 15 plus this one is X minus 1 whole square. Okay.
Yes.
Now U is a function of X kada, so I can calculate the force here. F is equals to minus of your du divided by your dx. Okay, so that is equals to minus of d. In the place of u, I'm writing here 15 plus this one is x minus 1 whole square divided by your dx. Differentiation of 15 0. X minus 1 మొత్తం ఏమనుకుంటాం మనము x అనుకో. How do you differentiate this one? Isn't it? Assume chain rule. Assume x minus 1 whole square is equals to some z. Okay, na?
Yes.
This one will be 15 plus of your z square అయిపోతుంది. So at the time this will become for me f is equals to minus of d into this will become for me 15 plus this one is equals to some z అనుకుందాం.
Yes.
This z, or you can assume this one as say for example of your x anything. So I'll take this one as of your x only. This is equals to x. That means this is x minus 1 whole square is nothing but of your x square divided by your dx. Can I write like this better?
Yes.
Now differentiation of 15 is how much? 0.
0, sir. Because
Differentiation of x square is how much for me? 2x. Okay. Keep back the value of x. Keep back the value of your x. So what I'll be getting? F is equals to how much I'll be getting this one? See right now for me. So this will be equal to your differentiation minus already ikkada undi kabatti this one is already minus here. So this will become for me minus of 2 into x value is how much already beta? X minus 1.
Yes.
This one x minus 1 whole square now. If I differentiate this total x minus 1 whole square, can you tell me what will be the answer for?
Sir, 2x only, sir.
Yes, beta. This completely x minus 1. I'm taking it, it's not x minus 1. This is x minus 1 totally I'm assuming as of your x.
Yes,
So
sir.
keep back that value of your x. So this will be your x minus of your 1. Isn't it?
Yes, sir.
This x minus 1 I'm assuming is as x beta. Already it is having in a square here. So it is your x square. Differentiation of x square is 2 into x.
2x.
Now
Yes.
keep back the value of your x. X value is how much for me? X minus 1.
minus
So it is minus of 2 into your x minus 1 part of relation.
Yes.
Okay. So that is the value of your x part of relation. So at mean position. Okay. So this total value I'm taking it as right now. Say for example, at mean position, x minus 1 will be equal to how much beta? 0. అంతే కదా x కాదు అది మొత్తం
Yes, sir.
so minus of k into x means at mean position, so this is the value of your force what we are getting right. So I'll write here right now at mean position number A, at mean position, at mean position x minus 1 must be equal to 0. That means x will be equal to how much beta of 1. So if
Yes.
I take x is equal to 1 here, so what is the minimum potential energy, can you tell me? X is equals to 1. So potential energy and kinetic energy will become how much, can you tell me right now? So U minimum will be equal to your how much? U minimum is equals to 15 plus, this one is nothing but of your, what is the formula for me? F is equal, U is equal to 15 plus x minus 1 whole square. X value how much you got already here? 1. 1 minus 1 whole square. That means this will become how much for me? 15 joules. Minimum potential energy.
Yes, sir.
Then total energy will be equal to how much for me? Total energy is equals to kinetic energy plus potential energy. Kada?
Yes, sir.
Isn't it? That means what is the total energy as given in the problem? What is the total energy as given in the problem? You see, total mechanical energy is given as
27.
24 joules.
Yes.
So we can calculate the maximum kinetic energy. Kada? So I
Yes,
can
sir.
write here total energy is equals to 27. That is equals to
Minus
kinetic energy plus potential energy is equals to 15. So K value will be equal to how much for me? 27 minus of your 15.
12.
So kinetic energy will be your maximum. That value will be equal to how much for me? 12 joules.
Yes, sir.
So that is the way. Just so see it once again. If you are having any doubt, please let me know. See the question once again better. See the calculation part. If you are having any doubt, please let me know.
Sir, at 0 plus 2x, sir, why have we taken minus 0?
Here formula minus ఉంది కదా.
Okay, okay.
F is
Yes,
equal
sir.
to minus of du by dx kada. This one is also minus here.
Yes, sir.
This is the total term like this.
Okay, sir.
0 plus 2x is nothing but of a 2x. So it is
Yes.
minus of 2. Okay. At mean position, this is, you should assume this totally as of x. This is in the form of like f to minus of your k into x. K అనేది constant or 2 వచ్చింది. In the place of x, it is x minus 1.
Yes, sir.
Okay na?
Yes, sir.
This is for your done beta.
Sir?
Yes, beta. If you have any other doubt, you please let me know.
No, sir, in the side box.
Fine na?
Yes, sir.
Write one more question beta. Find the ratio of kinetic energy and potential energy when the particle executing SHM. SHM is at A by 2 from the mean position. A by 2 from the mean position. Where A is the amplitude beta. Okay, na? Come on, tell me the answer. You can do it out. You know the kinetic energy formula, you know the potential energy formula. Just take the ratio of that one and let me know what will be the answer for that. What is the kinetic energy formula, beta? Kinetic energy is equals to half into m into v square, no? So that is equals to half into m. V is equal to how much for me? Omega square into a square minus of x square. This is the kinetic energy.
Yes.
So that means x how much in the problem? A by 2. Given it is asking it x is equals to a by 2. What is the ratio? So can you tell me what will be the kinetic energy, beta? Kinetic energy will be equal to half into m into omega square into a square minus x is
A by
equals
2.
to by 2 whole square. That means a square divided by 4.
Yes, sir.
Okay. So a square divided by 4 ఎంత అవుతుంది ఎంత అవుతుంది చెప్పు. So this one is half into m into your omega square into 1
3a
minus 1 by
square
4.
by
ఎంత అవుతుంది
3a,
అది? 1 minus 1 by 4.
3a square by 4. sir.
3 square by 4. That means this will become for me how much for me?
3:1,
3
sir. Is it?
go to side 3 by 8 m into your omega square into your a square. This will be the kinetic energy.
Yes, sir.
The same way, what is the potential energy? Can you tell me? Potential energy is equals to, what is the potential energy formula? Half into k into x square.
Yes, sir.
Half into k, x value is how much for me? A by
A
2. So
by
it is a square.
4.
Antena? So this one will be equal to for me. This one is will be equal to 4 to the 8. So this will become for me 1 by 8. K is equals to m into your omega square into your. This one is nothing but of your.
A square.
Now just tell me the ratio of that one.
3:1, sir. 8, 8 cancel.
3:1. So
M omega square cancel. A square cancel.
energy. Yeah. So if I take both, it will get cancelled. 1 by 8, 1 by 8 gets cancelled. So 3 by 1. So that is your
Yes.
answer. So 1 is your answer for this.
Yes, sir.
Chalo. One more question. The potential energy of a simple harmonic, the potential energy of a simple harmonic oscillator of mass 2 kg in its equilibrium position is 5 joules. First off, if amplitude of oscillations is 0.01 meter and total energy is 9 joules. find the time period. Find the time period. Sure. The potential energy of a simple harmonic oscillator of mass. Just write what is the given data for us. Mass is given beta. Mass is equals to 2 kg. In its equilibrium position, the potential energy is given for me. Potential energy is matlab U. U will be equal to how much for me? 5 joules. If the amplitude of the oscillation, that means A value is 0.01 meter, and the total energy, that means E, total energy is equals to 9 joules. Find the time period of this oscillation. That means T is equals to how much? Okay. Now you know that what is the relation between the potential energy and kinetic energy beta? You know that sum of your kinetic energy plus potential energy is equals to total energy. At mean position, kinetic energy is maximum or minimum beta? At mean position, kinetic energy is maximum.
Yes, sir.
Energy is given how much for me? 5. Total energy is nothing but 9. So kinetic energy will become how much for me beta? 9 minus 5, that will be equal to 4 joules. Okay, so that will be your kinetic energy. So kinetic energy is equals to your 4 joules. Okay, na?
Yes, sir.
Clear? Then
Yes, sir.
what will be the maximum kinetic energy beta? Can you tell me? Maximum kinetic energy of the particle will be equal to your how much? How much it is? 4. So I can write here kinetic energy is equals to, what is the formula beta? Half into m into your x is nothing but of your a square into your omega square. It will ask question.
Yes, sir.
At extreme position or at the mean position 0. So at extreme position, if I'm writing, maximum kinetic energy will be equal to half into m into your a square into your omega square part of relation. Okay.
Yes, sir.
So that is equals to half. Mass is given how much for me? 2. Amplitude is given as 0.01 whole square into your omega square. So this two will get cancelled right now here. So omega value will be equal to your how much for me? Omega value will be equal to, so this is square తీసేసుకుంటే ఇది ఎంత అవుతుంది? 2 square కాబట్టి ఈ స్క్వేర్ కూడా వెళ్ళిపోతుంది. So this will become for me 2 divided by 0.01. అంతేనా?
Yes, sir.
This 2 square now beta. This is also square. I'm removing this square. So omega is equals to 2 by 0.01. So time period will be equal to how much? We know the formula. T is equals to 2 pi by your omega. That is equals to 2 pi divided by omega. Omega is 2 divided by 0.01. So this 2 and this 2 will get cancelled right now for this one. So this will become for me how much beta? Pi into 0.01 means this will become for me pi by 100 seconds.
Yes.
Ante?
Yes, sir.
Equal to pi by over 100 seconds. So this is your answer. Clear beta?
Yes, sir.
At mean position x will become 0. At mean position x will become 0. You form, what is our formula? This one. So at mean position x is becoming 0. That is the reason half into m into omega square into a square. We are getting maximum kinetic energy
Yes,
at the
sir.
mean. Must be equal to 0, not a beta. Okay. Chinda?
Yes, sir.
Recording option on the